This is a story about Ned and Larry, two little proteins trying to find their way in the big, wide cell. Ned's just been translated on a free ribosome and folded in the cytoplasm. He's about to undergo post-translational import. Hey, Ned, how's it going?
Great! This place is pretty new to me. Who are you?
I'm your narrator. Don't worry about it. Why don't you go check your signal patch and tell us where you'll be going today?
Looks like today I'm headed to the nucleus. Whoa, my signal patch seems to be directing me there already.
Sounds like fun. Uh-oh, you look too big to go through that nuclear pore by free diffusion. Guess you'll have to convince a nuclear transport receptor to release some GDP so you can hitch a ride into the pore.
Hey you, over there. Can you help me get into the nucleus? Well, you are a pretty good-looking protein, and I recognize that signal patch of yours. I suppose I could help you out.
So the receptor releases a molecule of GDP, which allows it to bind to the protein. It also binds to the inner wall of the nuclear pore. The receptor can then bring the protein through the nuclear pore and unload it there by binding to a molecule of GTP.
Hey, look at that. I'm exactly where I needed to be. Now I can do all sorts of cool stuff, like help out in the transcription of genes.
Fantastic! It's always nice to get where you're going. Let's go back to the cytoplasm to check on Larry, our other protein friend. You can't quite see him yet because he hasn't been translated. Larry is about to be co-translationally imported to the ER. Let's watch. First, a ribosome starts to translate a protein, starting at the NH3 end. At this end, there's a little signal that is recognized by an SRP, or signal recognition protein, which then binds to the signal. The SRP, ribosome protein complex, then docks with an SRP receptor on the endoplasmic reticulum. At this point, translation continues, while the ribosome is attached to the ER. When translation is finished, a signal peptidase cleaves the signal and chaperones attached to the protein to help it fold properly and at an appropriate time. Hey, Larry, nice to see you.
Where am I? What's happening?
We were just translated and imported into the ER at the same time. Pretty tiring stuff for a little protein. Is this your last stop for the day?
Nope. I have other signals after the first ER one that tell me that I'm going to the Golgi. Someday, I'm going to help phosphorylate other proteins as they pass through.
In that case, you'd better meet the COP proteins. COP2 attaches to part of the ER to help form a vesicle which will take you to the cis end of the Golgi.
Hey Larry, you ready to go?
Sure. But how does this vesicle know where it's going? I don't want to end up in the wrong place.
The vesicle has signals on its outside called V-snares that interact with signals on the target membrane called T-snares. These two signals interact to make sure the vesicle gets to the right membrane and the two membranes fuse properly.
Hooray! I'm in the Golgi, just where I needed to go.
And that's the end of that. Ned and Larry are both in their proper places in the cell. Now they can do their jobs properly, and all because of intracellular transport.